IoT Internet of Thing Unit 3 for RGPV Exam 2023 notes are in comment section. Basics of IoT networking. IoT networking involves connecting physical devices, sensors, and other objects to the Internet or other networks. It uses a range of communication protocols, such as Wi-Fi, Bluetooth, ZigBee, and cellular networks, to transmit data between devices and to the cloud. IoT networks can be categorized based on their range and data transfer rate, such as LAN, WAN, and MAN. IoT components. The basic components of IoT include 1. Sensors and actuators. These are the physical devices that collect data and perform actions. 2. Network connectivity. This allows the devices to connect and communicate with each other and the cloud. 3. Cloud infrastructure. This provides storage and processing capabilities for the data collected by the devices. 4. Application software. This enables users to access and interact with the data collected by the devices. Functional components of IoT. The functional components of IoT are 1. Perception layer. This includes the sensors and other devices that collect data. 2. Network layer. This includes the communication protocols and networking devices that enable data transmission. 3. Service layer. This includes the cloud infrastructure and data processing services that store and analyze the data. 4. Application layer. This includes the software applications that allow users to interact with the data. IoT Service-Oriented Architecture. IoT Service-Oriented Architecture, SOA, is an approach to building IoT systems that emphasizes the use of modular, loosely coupled services. In an IoT SOA, the different components of the system are organized as services that can be accessed and combined as needed. This allows for greater flexibility and scalability in IoT systems, as well as easier integration with other systems and services. SOA is typically used in cloud-based IoT systems, where the services can be hosted and managed remotely. IoT challenges. IoT faces several challenges, including 1. Security. IoT devices are vulnerable to cyber attacks and data breaches, which can compromise user privacy and cause harm to physical systems. 2. Interoperability. IoT devices from different manufacturers and with different protocols may not be compatible with each other, making it difficult to create a cohesive system. 3. Scalability. As the number of IoT devices increases, it becomes more difficult to manage and process the data generated by them. 4. Power consumption. Many IoT devices run on batteries, which can limit their lifespan and require frequent replacement or recharging. 5. Data management. The large amounts of data generated by IoT devices require efficient storage, processing, and analysis. 6. Standardization. The lack of standardized protocols and technologies can hinder the development and adoption of IoT systems. 6. Low-PAN. 6. Low-PAN, IPv6 over low-power wireless personal area networks, is a protocol that enables the transmission of IPv6 packets over low-power wireless networks, such as ZigBee and Bluetooth. It allows for the integration of low-power IoT devices into larger networks, while also providing interoperability with existing IP-based networks. 6. Low-PAN addresses the challenges of low power consumption, limited bandwidth, and small packet sizes commonly found in IoT networks. IEEE 802.15.4 IEEE 802.15.4 is a standard for low-rate wireless personal area networks, LRWPANs, which are used in IoT applications. It specifies the physical layer and medium access control (MAC) layer protocols for LRWPANs, which operate on low-power devices and use short-range wireless communication. IEEE 802.15.4 provides a standardized protocol for IoT devices to communicate with each other and with other networks, such as Wi-Fi and Bluetooth. It addresses the challenges of low power consumption, low data rates, and low-cost implementation for IoT devices. ZigBee and its types. ZigBee is a wireless communication standard that is designed for low power, low data rate, and short-range applications. It is based on the IEEE 802.15.4 standard for LRWPANs and is used in many IoT applications, such as smart homes, industrial automation, and healthcare. ZigBee has several types or profiles that are optimized for specific applications. Some of the most common types of ZigBee profiles are 1. ZigBee Home Automation. This profile is used for smart home applications, such as lighting control, temperature monitoring, and security systems. 2. ZigBee LightLink. This profile is used for wireless lighting control applications, such as dimming and color control. 3. ZigBee Smart Energy. This profile is used for energy management applications, such as smart metering and demand response. 4. ZigBee Healthcare. This profile is used for healthcare applications, such as remote patient monitoring and medical device control. 5. ZigBee Remote Control. This profile is used for remote control applications, such as home entertainment systems and home automation. 6. ZigBee Building Automation. This profile is used for commercial building automation applications, such as lighting, HVAC, and access control. Each ZigBee profile specifies a set of communication protocols and data formats that are optimized for the specific application. This allows for interoperability between devices from different manufacturers and for easier integration into larger IoT systems. RFID. RFID, radio frequency identification, is a technology that uses radio waves to wirelessly identify and track objects or people. It is commonly used in supply chain management, inventory tracking, access control, and other applications that require real-time identification and tracking. Features of RFID. 1. RFID tags or transponders can be read remotely, without the need for line of sight or direct contact. 2. RFID technology can read multiple tags simultaneously, allowing for rapid and efficient tracking. 3. RFID tags can be attached to almost any object, including products, containers, and vehicles. 4. RFID tags can be passive or active, with active tags containing their own power source. Working principle of RFID. RFID consists of three main components: a reader, an antenna, and an RFID tag. The reader emits a radio frequency signal through the antenna, which is received by the RFID tag. The tag uses the energy from the radio signal to transmit its own unique identifier back to the reader, which can then be used to identify and track the object associated with the tag. Passive RFID tags do not have their own power source and rely on the energy from the reader to transmit their identifier, while active RFID tags have their own power source and can transmit their identifier over longer distances. Applications of RFID. 1. Supply chain management. RFID is commonly used to track products and inventory in warehouses, shipping containers, and retail stores. 2. Access control. RFID is used for access control in buildings, parking lots, and other secure areas. 3. Asset tracking. RFID is used to track high-value assets, such as vehicles and equipment, to prevent loss or theft. 4. Healthcare. RFID is used for patient tracking, inventory management, and medication administration in hospitals and other healthcare facilities. 5. Livestock tracking. RFID is used to track and monitor livestock, such as cattle and sheep, for identification and disease control purposes.